Hi math students, it's Mr. Hatchgasson, and today we're going to learn how to solve two-step equations using inverse operations. Now, so the word inverse operations, firstly, if we have a look at these symbols here, that's the addition symbol, that's the subtraction symbol, multiplication and division. So which ones are inverse operations? So we call each of these symbols an operation in mathematics. So we want to know which ones are inverse operation, and the word inverse means opposite. So the opposite operations are these two. So addition is the inverse operation of subtraction, or subtraction is the inverse operation of addition, because when we want to undo addition, we would do subtraction, or if we want to undo subtraction, we would do addition. So these two are inverse operations. Likewise here, we have multiplication and division. So the opposite of timesing, or the opposite of multiplying, is dividing, and the opposite of dividing is multiplying. So these two are also inverse operations. So it's really important that we understand this bit before we move on. Now, so solving one-step equations. So what this is saying is an amount, x can be any amount. Well, actually, x can be one amount. In this case, x can be one amount, but the variable can be represented by any letter. It could be x, it could be y, it could be a, b, c, d, or any letter you want. But traditionally in maths, we use the letter x. So a number plus 6 should give us 8. Now, hopefully you should be able to recognize that that number will be 2, because 2 plus 6 makes 8. So this is quite easy to solve. However, when we have more difficult numbers, and as the equations become more and more difficult, it's really important to understand how we can solve this equation using a set of processes. So what we need to say is, what is actually happening to x right now? Well, what's happening to x is that we're adding 6 to x, and then we will get 8. So I can draw a little table here, and I can say to myself, what is happening to x? So what is happening to x? Well, we're adding 6. So what do I need to do? Well, the inverse operation of adding 6, or the opposite of adding 6, is to subtract 6, because ultimately we want a situation where x is on its own, x is isolated, and then we know that individual value of x. So the opposite of adding 6 is to subtract 6. So we would have to subtract 6 from both sides of the equation, and the sides of the equation is split by the equal sign. So on this side of the equation, I'm going to subtract 6 to get rid of this positive 6, or this addition of 6. So I will subtract 6 here, and whatever I do to this side, I will have to do to the other side of the equal sign as well. So I'm also going to subtract 6 from 8. So 6 minus 6 is 0, so we're left with x, and 8 minus 6 is 2, so we're left with 2. Therefore, x is equal to 2. And this is the value of x. So if we follow this process, it would be quite easy to find what the value of x is. And like I said, with this equation, it's quite a simple one, so we'd be able to tell by just looking at it. But this method really comes in hand where we have more difficult equations. So let's have a go at this one. So again, what is happening to x here? So I'm just going to rub these out. So what is happening to x? Well, we have x and we're subtracting 4 from it. So what's happening is a subtraction of 4. So what we need to do is the inverse operation. So the inverse operation to subtracting 4 is adding 4. So I need to add 4 to both sides of my equation. And the reason why I add 4 is because I want to get rid of this minus 4. I want x to be on its own. And what I do to one side, I have to do to the other side as well. So minus 4 take away 4 is going to be 0. And then so we're left with x. And then we can say x plus 0. But we don't really need to write the 0. But just to see what's going on. So we have x that stays as it is. Minus 4 plus 4 is 0, and 9 plus 4 is equal to 13. So x plus 0 is equal to 13, therefore x is equal to 13. And this bit here, we don't actually need to do the bit where I wrote the 0, but it was just so you can see what happens when we do the inverse operation of subtracting 4. And if we substitute x into our equation, so if instead of x we had 13, 13 minus 4 is equal to 9. Therefore, when x is 13, this statement here is true. 13 minus 4 is equal to 9. All right, so let's move on. And now, what do we do when we are multiplying or dividing x? Now, the algebra notation, 2x means 2 times x, but in algebra, we don't write the multiplication sign. So rather than writing 2 times x, we simply write 2x. Or rather than writing 8 times x, we just write 8x. So what's happening to x? X is being multiplied by 2. So a number multiplied by 2 should give us 6. Now again, this is quite straightforward, and hopefully you should be able to recognize that that number is going to be 3, because 2 times 3 is equal to 6. But again, we need to understand what's happening with the inverse operations to be able to solve this, especially where we have more complex equations. So the opposite of multiplying by 2, so again, what's going on? What is happening? And what I need to do. So we're multiplying by 2, and the inverse operation, the opposite of multiplying by 2, is dividing by 2. So I need to divide both sides by 2 now. So I'm going to write this here. 2x is equal to 6. Because I'm multiplying x by 2, I'm going to have to divide x, or 2x by 2, and I will also have to divide 6 by 2. And again, in algebra, we don't use the traditional division sign. We simply use fraction signs. But a fraction is essentially a division problem. So 6 over 2 is the same as 6 divided by 2. So that's another bit of algebra notation which you need to know. And if we simplify this, well, 2 divided by 2 is 1. So we're left with 1x is equal to 6 divided by 2 is 3. And 1x is the same as x. So in algebra, when we have 1 lots of x, we simply just write x as opposed to having that extra 1. So 1x is equal to 3, or x is therefore equal to 3. All right, so let's this example. Again, you can pause the video if you want and have a go at this, but what's happening to x? Well, we're multiplying x by 8. So we are multiplying x by 8. So the opposite or the inverse operation of multiplying by 8 is to divide by 8. So I need to divide both sides of the equation. Don't forget, it's always both sides. Whatever you do to one side, you have to do to the other side as well. So 8 divided by 8 is 1, so we're left with 1x, and 32 divided by 8 is going to be 4. So x is equal to 4. And we can substitute this value of x into the original equation to see if that holds true. So 8 times 4, so in place of x, I'm going to write, in place of x, I'm going to write 4, is in fact equal to 32. So this statement is true when x is equal to 4. Right, now if I just rub everything I've done here, and now what we have is x over 2. So this time we are dividing x by 2. So the opposite of dividing by 2 is to multiply by 2. So again, you can draw your table out if you want. So we are dividing by 2, x is being divided by 2. So what we need to do, what I do, is to multiply by 2. So I'll have x over 2 multiplied by 2, and I'm going to write 2 as 2 over 1 because 2 over 1 is still 2. But this way, when you're doing your fraction multiplication, you won't be confused as to whether you need to multiply this by x or by the 2 on the denominator. And whatever I do to one side, so if I multiply this side of the equation by 2, 2, and we'll have to do the same. The other side is going to be 6 times 2. Well, 6 times 2 is 12. And what we'll get is 2 times x is 2x, and 1 times 2 is 2. And 2 divided by 2 is 1, so these two cancel out. So what we're left with is x is equal to 12. And again, that is true because if instead of x we had 12, 12 divided by 2 is 6. So when x is equal to 12, this statement is correct. And again, you don't need to do these steps once you become quite comfortable with what you need to do. So if we have a look at this example, what we're doing to x, well, we're dividing x by 3. So the opposite of dividing by 3 is going to be timesing by 3. And if I just rub this bit out as well. So we're dividing by 3. So what I need to do is to multiply both sides by 3. So as we saw in the previous example, the 3's will cancel out. And 7 times 3 is 21. So x is equal to 21. And again, if I substitute 21 into this equation, 21 over 3, or 21 divided by 3, is equal to 7. All right. Now, let's make this a bit more complicated now. So 3x plus 6 is equal to 24. So now we have two operations that are happening to x. We have two operations that are happening to x. So x is being multiplied by 3. And also, so x times 3 means x is being multiplied by 3. And then we're also adding 6 as well. So the two inverse operations that I need to do is to divide by 3 and then subtract by 6. Now, you may ask yourself, which one do I do first? Do I start by dividing both sides of the equation by 3, or do I start by subtracting 6 from both sides of the equation? Now, I've got this shoe and socks here, and this is going to tell you, or hopefully this will explain why or which one of these two operations we do first. Now, let's think about the order of operations, BIDMAS, which stands for brackets, indices, division, multiplication, addition, and subtraction. Now, when we are doing operations, we follow this order. So for instance, division would come before subtraction. However, now we are undoing the operations. So to undo the operations, we have to follow the opposite way around. It's almost like putting your socks on and then your shoes on. So usually you would put your socks on first and then your shoes on. However, when we take these off, you would take your shoes off first and then your socks. So the order reverses. So it's socks, shoes, but then when you're taking them off, it's shoes, socks. So now, because we are undoing the operation, because we want to get rid of this addition of 6, and because we want to get rid of this multiplication by 3, the first operation that we do is going to be subtraction, because we're going this way up. So I have to subtract 6 from both sides. So 3x plus 6 equals 24. Well, if I subtract 6 from both sides, what I'll end up with is 3x plus 0. I don't need to write that down. 6 minus 6, positive 6 take away 6 is going to be 0. And 24 take away 6 is 18. Now I have a one-step equation. So similar to what we saw on the previous slides. 3x is equal to 18. So I've done this bit. Now I need to divide both sides by 3. So 3 divided by 3 is 1. So what we're left with is x is equal to 18 divided by 3, 6. And we've done this operation as well. And now if I substitute x into my original equation, let's see what we get. So 3 times 6 is 18. 18 plus 6 is 24. So when x is equal to 6, this statement is true, or this equation is true. Right, let's rub this off and let's try another example. So now we have 32 is equal to 2y minus 10. Now this might look a bit tricky. However, what I'm going to do is to rewrite it in the format that we're more used to and more comfortable with. So I'm going to write 2y minus 10 is equal to 32, because this is the same as this. Now, what is happening to y? Well, we're multiplying y by 2, and then we're subtracting by 10, so we have to divide by 2 and add 2 as well. Now again, let's think about bid mass. So when we're doing the operations, we go from B to S, but now we're going from S to B. This is when we undo, and this is when we do the operations. So I need to undo the operation. So the first operation that's going to come is going to be addition. So this is the one I need to do first. I need to add 10 to both sides. So we're going to be left with 2y minus 10 plus 10 is 0 is equal to 32 plus 10 is 42. So 2y is equal to 42. Now I need to divide both sides by 2. So what we get is 2 divided by 2 is 1. So y is equal to 21. And that holds true as well, because 2 times 21 is 42, and 42 minus 10 is going to be 32. All right, and again, you don't need to do all of these bits once you're very comfortable with solving equations, but I just want you to see what is going on. But as I said, once you're comfortable, you can just go about doing the equation without having to do this bit and this bit as well. Right, so let's try another example. So now we have a two-step equation, but this time we're dividing x by 2. So the opposite of dividing by 2 is to times by 2. So the two things that we need to do is we're dividing x by 2, so we need to times by 2, and then we're adding 4, so we need to subtract 4. So first I'm going to subtract 4 from both sides. And notice this is not 2 minus 4, this is x over 2 plus 4 minus 4 and 8 minus 4. So don't get confused here. So x over 2 stays as it is, and then 4 minus 4 becomes 0, so we don't need to write that, and then 8 minus 4 becomes 4. Now the opposite of dividing by 2 is to times by 2. So I'm going to multiply both sides by 2. So the 2 and the 2 cancel out. So x is equal to 4 times 2, which is 8. And we've done both operations that we needed to do. And now we have the value of x. And if I substitute x into this equation, it will become 8 over 2 plus 4. What does that give us? Well, 8 over 2 is 4. 4 plus 4 is 8. So when x is 8, this statement is true. Now let's have a go at this one over here. So we're subtracting 2, therefore the opposite of subtracting 2 is to add 2 to both sides. So x over 5 stays as it is, minus 2 plus 2 is 0, and then 3 plus 2 is 5, and then the opposite of dividing by 5 is to times both sides by 5. So this 5 and this 5 cancel out. So what we'll have is x is equal to 5 times 5, which is 25. Once again, let's substitute this value of x into our equation. So what we get is 25 over 5 minus 2. So 25 divided by 5 is 5, minus 2 is 3. So when x is 25, this equation holds true. All right, so if I just rub this off. Now we have a slightly different example. So this time we have x plus 3 divided by 2. So what that means is that both terms, both x and 3, is being divided by 2. So this time, rather than getting rid of this addition of 3 first, we have to get rid of this denominator. So to get rid of division by 2, we have to multiply both sides by 2. So what we get is x plus 3, because the 2's cancel out, is equal to 14. 7 times 2 is 14. Now what we have is a one-step equation, so I need to subtract 3 from both sides, and what we'll end up with is x is equal to 11. And now let's sub 11 back into this equation here. Let's sub 11 back into this equation, and what we get is 11 plus 3 divided by 2 is equal to, well, 11 plus 3 is 14. 14 divided by 2 is 7. So when x is equal to 11, this equation holds true. notice if you didn't get this value of x, if you got, say, 12, for instance, then this would no longer be true, because 12 plus 3 is 15, and 15 divided by 2 is going to be 7.5. So you can check to see if your x value is correct by substituting that x value into the equation. And I've got this equation here just so you can see what the difference between this and this is. Here, because both x and plus 3 are being divided by 2, we need to get rid of this division first. Whereas here, because only x is being divided by 2, we need to get rid of the addition first. So if we go about doing this one, I'm just going to draw a line here. So subtract 4 from both sides. 4 minus 4 is 0. And I think we actually did this equation earlier, didn't we? This is one of the earlier ones. Right, so I just wanted to show you the difference between this and this, but I suppose we can quickly solve this just so you can see how they are different. X divided by 2 plus 4 is equal to 8. Subtract 4 from both sides. So what we get is x over 2 is equal to 4. And then we multiply both sides by 2. And then this and this cancel out. So we get x is equal to 4 times 2, which is 8. One last example before we wrap up the lesson. So if I just delete my notations, and now we have ax minus 3 over 5 is equal to 9. So again, because both ax and minus 3 are being divided by 5, we need to get rid of this division first. So I'm going to multiply both sides by 5. So this 5 and this 5, the multiplication of 5 and the division of 5 cancel out. So what we're left with is ax minus 3 is equal to 9 times 5, which is 45. Now, the opposite of subtracting 3 is to add 3 to both sides. So what we'll end up with is minus 3 plus 3 is 0. So we have ax on this side is equal to 45 plus 3 is 48. And now the opposite of multiplying x by 8 is to divide by 8. So we have to divide both sides by 8. 8 divided by 8 is just 1, or you can think of them as cancelling out. So x is equal to 48 divided by 8 is 6. So when x is 6, this statement holds true, and we can try this out. So instead of x, I'm going to substitute 6 minus 3 divided by 5. Now, 8 times 6 is 48. 48 minus 3 is 45. So I'm just going to rewrite this as 45 over 5. And 45 over 5 is equal to 9. So when x is 6, this statement holds true. So the key takeaways here is to understand what we mean by inverse operations. And when solving equations, you need to apply the inverse operations to isolate x, to get rid of all the operations that are happening to x. And therefore, you'd be able to solve the equation. I hope you found this useful, and have a very good day. Bye.